Hi everyone, welcome back. In this video we are gonna talk about camera calibration. Also, my plan is coding from scratch so we can learn together and we can go step by step and we can see how it looks like and you will see how easy it is. And before starting, I want to talk about a bit camera calibration. It's very important and maybe I can open my camera a bit to show you. Okay, hi. Camera calibration is very important in computer vision because but in some cases you don't need to calibrate your camera. For example, let's say like you watching me in this camera, and let's say you want to make face recognition, right, or human detection. In this kind of cases, if your camera is not a fisheye, as you can see here, there is no much distortion in my camera webcam, so I don't need that. I don't need camera calibration. I can directly make face recognition, human detection. These kind of things you don't need to calibrate your camera. So you need to know this first of all, because people are sometimes just thinking, okay, I'm making computer vision, I need to calibrate my camera. You don't need in every cases, but in some cases you must calibrate your camera. For example, if you are working in a kind of image processing for industrial application, for example in a conveyor belt, something screws are passing through and you need to measure the screw lengths, or in photogrammetry you need to measure some 3D coordinates, or mostly in stereo vision you need to measure the distances. In those cases you must calibrate your camera and you must calibrate it properly, very accurately. But yeah, this is important. You first of all, you need to decide you need camera calibration or not, and how accurate you need. That's also important. According to your accuracy, you need to decide also, yeah, because you need to change your calibration methods. Here I have two calibration method. One is ChArUco board, one is chessboard. Chessboard is the most known one, but less accurate one. Why less accurate? Because corner detection is not easy comparing to the ChArUco. So this is the first one, and the second disadvantage of this chessboard, to calibrate you need to fully show all the squares in the image. But for the ChArUco, even some of those are inside the screen, like this for example, it's enough. You don't need to fully show even. Yeah, this is important, but ChArUco is more accurate than the chessboard. So for this video I'm gonna use ChArUco. Also, another thing, if you need camera calibration, you need accuracy, you need to measure squares and the ChArUco marker edges very accurately. You need to measure them well, and because in the code part we need those information, and it's important also. Another one is the surface should be fully straight. Even there are some little distortion in the surface, it's gonna be problem. So my suggestion, you can print also laser printer. I will suggest if you need to print them, and after laser printer paper you can stick it into a glass. You see, this is a glass, because glass, we are sure glass is straight, so you can stick into a glass properly and you see a straight. Yeah, so we are gonna calibrate with this. The other things, of course, there are many things. For example, the I will just give an example in this video, but for example to my camera this chessboard a bit smaller, so if because I need to, if I want to work in this distance, then I need a bit bigger ChArUco board to be, because this is small and I need to go through all the parts of the frame. So if bigger, it's gonna be better accuracy. So but the distance also very important. Let me talk about it also. If you want to work in this distance, mostly your capture should be around this distance. for example, if you will work here, you don't need to put really behind your board. This is also important. Okay, these are some hint, and what I want, I will start to code part, but let me also show you here. Now I have in here some images which I already captured. These are not good ones because I just want to show for example purpose, but yeah, normally this should be all of the corner very well. And yeah, this is not very good, yeah, captures, because I wasn't very careful, so I just took around 40 images. So another question, there are many questions, but how many images you need for this purpose? Actually, around according to my experiences, around 30 or 60 is gonna be enough. Also, the number doesn't matter. For example, if you take always in this distance and always this kind of tilted images, it doesn't matter you are taking 1 or 10, because you always took the captures from same distance, from same perspective, so it doesn't matter. You need to go through the frame and you need to get the captures from different perspectives. That's important. So, but yeah, 30, 50 images is gonna be enough, even for a really accurate calibration. Anyway, now we can go to the calibration part. We need these headers for ChArUco, and at the end we need some we need to print the calibration file. And here my Pro, I need these libraries, but even in Visual Studio you can add those and you can work on. So I just like Qt, so I continue on this one. What we need to define something before starting. First of all, how many square you have in both horizontal and vertical in your board. So we can call square horizontal. So my horizontal number you can see here. So 1, 2, 3, 4, 5, 6, 7. So I will write here 7. And similarly, square vertical, I have 5. And what else I need is that marker length and the square length. So in the float, this part important, you need to define all these parameters. So let's start with square length is equal to, in here it's gonna be meter, so you need to measure accordingly. So here is gonna be 2 centimeter. I already measured. So similarly also for marker length, which is inside, this is gonna be 0.015 centimeter. Okay, meter, yeah, but this centimeter. Okay. The next is we need to define our dictionary. Let me also talk again about it. So now I'm using the ChArUco's ChArUco markers as 6 to 6. So if you increase the dimension, it's gonna be more accurate detections. Yeah, but even, yeah, if you are using 4x4 ChArUcos, they are less accurate than the 6x6. So yeah, just keep in mind. So here we are gonna define dictionary ID, which is gonna be the 6x6, and this name was dictionary. Oops, 6x6. 250 is enough. So the next we are gonna define based on this dictionary ID our dictionary, and also we are gonna define our board. We are gonna define our detector parameters. So next we need these definitions. The first we need to define them as CV pointer, and here it's gonna be the dictionary. Okay, and here we can call it dictionary. Also, by the way, in my previous videos for in the OpenCV tutorials 1, I already have ChArUco Board tutorials, so you can also watch them. Here we are gonna call the predefined dictionary, which is based on our dictionary ID. Okay, so this is like this. The next we need to define our board, which kind of board we are using. We need to let the kernel know about it, so we are gonna do that via on the ChArUco and ChArUco board, and here we can call it board is equal to ChArUco and ChArUco board and create. Okay, it tells here what we need. So square x means square horizontal number, which is we can call square horizontal. Square length means just square y. We need first of all square vertical. Oops. Square vertical, and the next we need length, which is square length and then marker length. Square length and square marker length. Okay, and the lastly we need the dictionary, which we have defined. Dictionary. Oops. Okay, so this part is done. Now the next we can define our parameters. Okay, let's also define it as pointer, which is gonna be the detector parameters, again from ChArUco namespace. And what was the name? Detector parameters, and here we can call them detector params is equal to just again from ChArUco. I think we can get the default ones, which is like this only, but of course we need to create okay. So there are many parameters, by the way. You see here all these yeah, in my tutorial series we already talked about those. These are very important, by the way. Yeah, you must know about this, but for this video, so our focus is about the calibrating the camera directly. So these are about detecting the ChArUcos properly. All parameters matter, but default ones for us, at least for calibrating, enough. Okay, so the calibration function at the very end is gonna need some parameters, which is ChArUco corners and the ChArUco IDs. So we need to define them. Also it's gonna need some image size also it's gonna need, but it's easy. So we need to define them as math. Mostly math is gonna be accepted, so we can call this ChArUco corners, and also similarly all ChArUco IDs we need. These are, so it's gonna be in an order. So for example, corners are detected 0, 1, 2, 3, then it's belonging to the corresponding ID. So this information is gonna be go through to the function of the calibration at the very end. So also we need a size because it's gonna need image size also, but since we don't have different sizes, we are gonna give the same anyway. Now so the way I go through is, first of all, I got my captured images. So what I need is just getting this path, and I want to put it here. Just const string file path or images path, image path is equal to this one. So I need a for loop, of course, to go through all captured images. Here I will not check a very proper thing, so I have 43 images, so just I'm gonna write here 43. Even we can start from 1 to 44. It doesn't have to be very well coded, so just okay. And here I'm gonna get my image first of all by imread is equal to cv imread Okay, and here image path, and then plus to string, which is I, plus dot jpeg. Oops. And we can read grayscale more better. Oops. And read grayscale. And is it done? Yeah, it's done, I think. Next we can just show to test. So now we are going through each captured image, and we are gonna analyze each image, and we will collect our data into the ChArUco corners, ChArUco IDs accordingly. So here we can write just image, and next is image, and just put a weight key 0. Okay, we can run the code, I believe. Okay, you see they are coming one by one, so it's working. That's good. And the next we can detect our markers via the detect marker function, which is gonna be but we need to collect again our marker IDs per images. So we need to define again vector to keep all detector marker IDs per image. Okay, so here we can call my marker IDs, and also we need to define marker corners per marker for each marker. So for that, one vector is not gonna be enough, so we need to define two vectors. The first outer vector is gonna be belonging to each marker, and inside vector is gonna be belonging into the corners. So here we can call point, even float is okay, and this can call marker corners. Okay, and once these are done, we can call our beautiful function, which is detect markers. Okay, this one. So here we are gonna give our image as input, then we are gonna give our dictionary, which we have defined. We are gonna give our marker corners, okay, and we are gonna give our what was saying, IDs. Okay, marker IDs, and next we are gonna give our parameters, which is, yeah, even we are not giving, actually it was just getting the default one, but anyway. And yeah, this is done, but I want to see if it's working fine. So just calling again ChArUco draw detected corners, not corners, but draw something markers. Okay, this can work. Image is okay, but this is giving colorful color. Is it gonna work with? Let's see, with grayscale may it works. Corners, marker corners, and marker IDs. Okay, before running, let's go through what we are doing. Here, first of all, we are giving our image dictionary. So it's gonna give us as output marker corners, IDs, also this input we are giving. So these two things we are gonna get from this per image. It's gonna give us corner of each detector markers, also IDs. Let's see, is it working? I'm not okay, even grayscale is giving white. That's really great. I didn't know about this, so I thought we need to give a RGB image, but anyway, so it's working. So you see from 1, 0, 1, 2, 3, 4, so all the detected ChArUcos is giving. Yeah, I'm just curious if any frame it didn't detect well. No, it's detecting very well actually. Even there are some shinings. Okay, It's good. Anyway, so it's detecting now. Let's crash it, and next we need to interpolate these detected corners. What I mean is, so until now we just get each, let me run. So we just detected marker individually. Now it's gonna interpolate all through like in the chessboard. So it's gonna now intersect all the detected ones. Then it will use them in the calibration part. So we need to interpolate. For that, now we are gonna getting into the again for getting input for the calibration part. We need to define ChArUco corners and ChArUco IDs again to fill our all ChArUco corners, and because they are in mat format, as you can see, and ChArUco IDs. Okay, after that we can call what was the function name? ChArUco interpolate. Okay, there's only one. Here we need to give our marker corners again, then marker IDs, okay, and our image and our board, which we have defined above, I think. Yeah, our board and ChArUco corners. This one we need this output ChArUco IDs. So this is just gonna beautifully use all and give us these output, and once we got them, we need to push them into our main vector for calibration. Okay, all ChArUco corners dot pushback ChArUco corners per image, and all ChArUco IDs dot pushback and ChArUco IDs per image. Okay, that's great. And also we need this, but anyway, we can also define them. Since this is same for all, we can just call image dot size. Anyway, okay, it's gonna work, and it's done. I think it's done. Nothing wrong here. Okay, we don't need to even show anymore. So we got what we need from our 44 image. Next, we are going to the calibration part. We can do that. And here no need separated functions. So here we need to get camera matrices and distortion coefficients, which is both again gonna be in the type of math. If you are working with OpenCV, everything mostly for in the math type. Distance coefficients, we can call coefs. Okay, so also we need the rotation vectors and the translation vectors. So rotation basically about the perspective, dealing about the perspective. So these parameters are gonna be coming from our calibration function of the kernel. So but translation is about the distance of the camera. So for example, how far to the camera and which perspective in the real world. So these two is about that, rotation vectors and translation vectors. Okay, so basically like this. And the next, we can call our camera calibrate function, which is also based on the in the namespace of ChArUco. What was name? Calibrate camera ChArUco, since we are using ChArUco board. And here we need to give the inputs, which is we collected as all ChArUco corners, all ChArUco IDs, and the next also what is board. Again, it requires size is image size, or okay, and the camera matrix which we need, you will give it to us, and distance coefficients you will give it to us, and rotation vectors you will give it to us, and translation vectors you will give it to us, and all is done, and our calibration is done actually. So here we can even see how it looks like. So we can just print, we can write with cout, and here just rotation vectors, and why it cannot see, because of course this is a vector. Anyway, just give me distance coefficients and camera matrix, and also okay, I think it's done. Camera, calibrate camera. Okay. Okay, there are two function which is about error estimation, so this is returning error estimation. Anyway, we don't need that now. Let's run it and see how it looks like. Oops, which one taking long time? I don't know. Let's see. Oops. By the way, it gave us the parameters, but I'm just curious which one taking long. Okay, this part is not, because detection is faster, but calibrating is not, because again in the kernel side is trying to optimize everything. So it's giving us these distance coefficients and the camera matrices. So also it's giving us rotation vectors and the translation vectors. We don't need to see them for now. For this video, let's summarize simply what we are doing. If you need calibration, first of all, you are deciding you need calibration or not. If you need calibration, you must do it most probably accurately. If you need accuracy, and ChArUco is not a bad choice, it's good choice, I can assure you. So you need ChArUco board. For that, what we are missing for this video is about the ChArUco detection parameters, which is very crucial. In here you see these are very important because these are changing according to your ChArUco sizes. Yeah, there are many parameters about thresholds. Yeah, you need to check those separately because they are really details. Except that once you got all, then here we are easily just giving the proper inputs, and output is just giving us what we need. But as I said again, calibration is very important if you are dealing about an accurate measurement, let's say 3D coordinate measuring with in a real world application. If something going wrong in your application, most probably at the beginning you didn't calibrate your cameras properly. Also, this calibration is not you need to do one time, because calibration can be broken. For example, you calibrated today, but after these cameras are moved around and vibrated, or according to the temperature, their calibration can be broken. You need to calibrate again. So this calibration is a curse of computer vision, I can say. Yeah, if you need calibration, you need to be careful, and you need to be patient. And for this video, simply we see how we calibrated this. In the next video, we may see how to use this and how we can distort our video. Since this video is a bit longer, I don't want to do that in here. Thanks for watching, and see you in the next video.